Good evening, sir.
Hello, Murli.
Yes, sir.
I'm there. Let's wait for a minute or so, a couple of minutes. I think 6 o'clock already, but we'll wait and then we can start.
Definitely, sir. We'll wait, sir. Sir, did you get a chance to look at the Google response sheet?
I looked at it. There are very few questions. There are technical questions.
Right, sir. You can start with that one, and then after completing it, you can interact with.
Technical questions, I think TAs can handle.
All right.
We go in a technical part, then it'll like if some smaller one, then I can explain.
All right, sir.
Then we can start. Welcome everyone. So Murli, how should we do it? I'll go ahead and
Yes, sir. Yes, sir. Please go ahead, sir. Thank you, sir.
okay. So welcome to this online meeting, and then I think the course is getting over this week. So I thought I'll we met in between once. Now I'll meet you again to ask you how it is going, how you're feeling, and then anything which you want to ask. We'll try to answer technical questions also. But I think that those are better handled in the Q&A forum, which is already there, NPTEL. But still, you can switch on your videos and then we can have an interactive conversation. So yeah, please go ahead if you have any questions or you want to any query about the exam or anything. So, how did you like the course? You're able to understand what is going on, and did you find it easy? Did you find it medium? Did you find it difficult?
Yeah, hi, sir. It's
Hello.
Sandeep here.
Yeah, go ahead. Switch on your video so that we can.
Yeah, I have issue with my video. So the course was good, but whenever whatever concepts you have explained in properly in a depth way, that was much easier. If you look at last 5 episodes of the class, like you did you give an overview of SSB and blocks and PSS and all. So we did not got that in-depth idea, which would have been appreciated if we would have covered that also. I know time is a constraint for you. So yeah.
Okay, fine. I'll keep that, take that feedback.
And I have one question actually, and the question is, you have in one of the classes you have explained us multi-code word. If we started mapping each code word to particular layer, and you also mentioned like successive interface cancellation at the receiver end. So, but my question is like, channel doesn't know whether we are transmitting multi-code word or I'm a single code word. So I can go for zero forcing or a match filtering or a SVD based on number of TX and RX antenna, right? Is there anything specific like we have to take successive cancellation interface?
Yeah, when I teach that, what was the philosophy behind designing, coming up with an architecture like this, the way it is defined in the standard? If you see that if it is up to rank 4, right, there is only one transport block, correct? And if it is more than 4, if the rank is more than 4, you transmit basically more than 4 layers, then you transmit 2 transport blocks. So through that example, I was trying to explain that why 3GPP came up with this kind of architecture. So now if it is up to rank 4, you have transmit 4 layers, but you cannot do SIC because each one of them, I mean, it's 4 layers, but it is a single transport block. And the underlying transport block is only 1, right? So you cannot do SIC over there. But if it is more than, if you do rank is, or the layer is more than 4, then you can do SIC because you can remove SIC of second transport block. That you could do. Okay, right? So that is what I was trying to explain there. Now, the receiver architecture is basically vendor dependent, and that's the difference between a costly phone and a cheaper phone. Okay, if it is, let's say, if it is 5,000 rupees mobile, it will implement only MRC, but then you get a poor SINR. If it is 25,000 rupees phone, it will implement 0%. If it is 50,000 rupees phone, it will implement MMSC, and you get MMSC SIC. You can get the best SINR. So it depends on the receiver implementation. And typically it's a function of the cost also.
Okay, thank you.
Yeah. Any other questions, please? Anything
Hello,
you want to talk? Yeah.
Yes, sir. Hello, sir.
Hello.
My name is Vivek Singh. I'm a MSc scholar in IIT Madras. So,
Okay.
sir, I enjoyed this course a lot. Like
Okay.
after a very, to be honestly, after a very long time, I've enjoyed a course, some course this much. So
Okay.
all the courses, all the subjects we have learned in our from BTech to now for masters, it was like amalgamation of all those subjects. So I enjoyed this course a lot.
Okay.
Thank you, sir.
Thank you. Where are you working?
I'm working. I have joined a 5G testbed in IIT Madras also recently.
You're working with Ganti.
My guide is Arun Prachai Kanu, but I have joined 5G testbed also for experience
Okay.
last year. Sir.
Okay.
So sir, I have one request if it's possible.
Yeah.
Sir, can I get your MIMO lectures, notes or video, anything if possible?
I'm not done NPTEL for that.
Mhm.
And
Yes, sir.
so the videos definitely are not there. I'll think about the MIMO lectures. I've not made them open as of now.
Yeah, I was going through your page also. There are no lecture notes also. So
Yeah. I typically don't. I've not uploaded them. This is the first course I'm doing NPTEL. Okay. So yeah, I know there is a demand, but I'm still not fulfilled.
Please update in your website at least so that we can refer and understand.
Sure.
Yeah, lecture notes will also do, sir. Lecture notes will also do. Like.
And I'll think about it. I'm not promising anything.
Okay, sir. Okay, sir. Thank you, sir. There is no question. I just.
Okay. Good.
Hi, sir.
Hello.
I am Deepak. I am working in physics research. So first of all, very thank you for such a nice course. We have recommended a lot of people in our physical layers of development and design people are there. So
Okay.
this give a new way of thinking like how to design the system. So mostly here we are working on FR1. So I'm just asking to you like FR2 you discuss like there are no 2-layer MIMO means we are not means that is as per 3GP there are no 2-layer or means that is our design. We are designing
By
system.
design you can have. I mean, I don't go into details there, so you can like 3GPP the standard doesn't stop you from doing that. Okay, but typically you get 400 megahertz of bandwidth, and people are still struggling to like make this millimeter wave work. Okay.
Yeah, here we are means here also people are means like 3300. So there are also we are getting something like some coverage issue. Means,
Yeah, it is. So typically, yes. So first you don't forget about you don't bother about multiple layers. but it is, you get the coverage right. Because anyway, I have 400 megahertz of bandwidth.
So,
Right.
sir, I want to your view, like in future, is going to feasible, like with like a
People are, I tell you, people are looking at it as a fixed wireless system, wherein like you have even like or in a stadiums, okay, wherein there is a clear line of sight. But it's not going to replace or FR1 because of these coverage issues. Okay, and so but fixed wireless system FWA, fixed wireless access, this FR2 is being looked at positively. That's all. Okay, so that's why you don't see any deployment, and even for now, 3GPP is talking about FR3, right? Because FR2 was not very successful.
so FR3 will be lower side, like
Yeah, no, around like 12, 13 mega, 13 gigahertz.
okay, sir. Thank you very much.
Hello.
Hello.
Hi, Professor. Can I share my screen and I have some notes that I wanted to ask you questions on, if that's okay with you?
Yeah, it's okay. Yeah, we'll see how
Right.
we can answer.
Yeah. So, an introduction to me. I work for MediaTek in the UK as an RFIC design engineer on the 5G stuff. Well, I don't design much anyways these days, but so Professor, the question that I had was on your MIMO transmission 4, right? So basically, what I wanted to ask is that when the channel, where is my notes? Yeah, when the channel actually when you receive, so this is the signal that will be received by the UV and the so for the CSI-RS, so this is the H tilde. So how does channel first get rid of the H tilde? Because how does the EU get rid of the H tilde? Because it has no information about H tilde yet.
It is going to estimate that. It is going to estimate H tilde only. It doesn't need to estimate H and H separately. I think that's what I'm saying here.
Okay.
Okay, so you're right. And that's a pre-coded signal. So why should it care about H and V separately? It estimates H tilde.
Okay.
Okay, so and then it works with that H tilde.
I see. Okay.
Okay.
Okay. Thank you.
Pre-coded transmission. For unprecoded, there's no V, and then that's a separate deal. But here it is like it works with the pre-coded signal.
Okay. All right. Thank you.
Hi, sir.
Hello.
This is Sachin. So actually, I work in Silicon Labs. So actually, I have been working there for 7 years, and I work in this baseband only.
Well,
So
Silicon
actually,
Labs,
yeah, Silicon Labs, Hyderabad.
Okay.
So actually, I'm working in this WLAN, but I found this course is very useful because through this course, I was able to understand like how the things are designed in this physical layer, be it like any or whatever. Because ultimately we are using OFDMA because I worked in this 11AX, and so it's a very useful course for me, and I recommend it for like others also, just to try to understand how the systems are designed in the baseband.
Thank you.
Especially the MIMO course is like very useful, and it's a very useful course for like the engineers.
Thank you. I'm happy that you are able to learn something from it. That was the idea.
Yeah, sure.
Any other questions, please?
And
Sorry,
yes,
bro.
what's your take on in India currently? We are seeing a lot of people at Inode side using already made L1 stack, and we are not seeing much of a L1 development work. It's more of a support of a L1 work. So in industry, so what's your take on that? And this will going to change?
Sure. See, what happens is, L1 development is mostly over by now.
Yeah.
Okay, because 5G is like people are installing, right? And it'll be mostly like even same here. initial implementation of L1 is done at IIT-Kanpur. Now we are doing feature enhancements. Okay, so yes, but the feature enhancements also like we are working on, for example, we are improving our SRS. We are working on SRS transmission. How do you design receiver for that? So it will be feature addition like that. But completely building this L1 will only happen for now 6G. Okay, for that you will have to wait.
Thank you.
Yes, please go ahead.
Yeah.
Anything?
Hello, sir.
Yeah. I'm sorry, I'm
Yeah.
eating something in between. But you please go
Yeah.
ahead.
Hello, sir.
Hello.
Yeah. uh, Good evening, sir. Actually, I have two questions. I am working on downlink CSI-RS in Samsung, like mostly related to the channel state information only.
Hmm.
So first question is like it's related to SRS.
Hmm.
So usually in the TDD mode, sometimes GNodeB will configure SRS and along with CSI-RS, right? But sometimes like network may use SRS measurements instead of CSI-RS.
Yeah.
Yeah. But what all things we can get from the SRS usually? Because like mostly I will see the some rank difference which is reported by the CSI-RS and SRS.
The thing is, I think we are mixing too many things here. SRS is for uplink and CSI-RS is for downlink. They are exact opposite counterparts. Okay. Now, typically, what could happen is you could use. So if it is a FDD system, it depends on the implementation. I don't know what is implemented in Samsung. So if it is a TDD implementation, and if the calibration between uplink and downlink is achieved, okay, uplink and downlink are calibrated, then you could use the SRS channel measurements for the downlink pre-coding also. Okay.
Yes.
But the uplink and downlink transceiver chains have to be properly calibrated for between the UE and the base station. Typically, which doesn't happen. That's why. Calibration is a difficult task to achieve. Okay. Right. So you might get some even if you claim that it is calibrated, you might get some rough channel estimate or the idea of the channel from the SRS if it is a TDD system.
Yeah.
Okay. Then you could do based on that you could send pre-coded CSI-RS and then get better information about the channel from the CSI-RS. Okay. So that you could do.
Okay. Yeah. Yes.
Now, so that's what probably you are seeing. Okay. So typically, but what happens is, and that's what is happening in our system. Then we still our TDD calibration still we don't have. So we, even though it is a TDD system, we send CSI-RS. We report back the CQI information, and then we use that to CQI basically and PMI, and we use that pre-coded matrix to pre-code the data and then send it to the user in the downlink. That's what we are doing.
Okay. And so by using SRS, mostly we will get PMI only, or like we can get CQA also for the downlink, because like SRS, I think it doesn't convey any interference related things as far as I know. So, but calculating CQA requires interference measurements also, right?
If you have, true. So even then, it depends on how you use it. Okay, you could SRS is you are right, and SRS like CQI is basically the receiver UE is reporting back and whatever the SINR is able to calculate, it will feed back. Okay. Right. So, but SRS will give you the channel information. How do you use it? That is the receiver implementation.
Okay. Yeah. So we have like choice to choose between whichever is flexible at that point of time. Like
Not, see, if your TDD system is properly calibrated, then you have a choice.
okay.
If it is not calibrated, it's a TDD system, then you don't have a choice. You'll have to use CSI-RS. Okay.
Oh yeah, okay. Yeah, I got it. In TDD, if it is calibrated, we can freely use SRS. Otherwise, like it's like better to use CSI-RS even if it's a
CSI-RS,
TDD.
yeah. And even if it is MDD system, people do sophisticated signal processing, then also you could use SRS to find out the statistical information. That also could be done. Okay, because channel statistics don't change across uplink and downlink, but it's just that the instantaneous gains change. Okay, so you could do that. People we understand that kind of research also. We do that. Okay, so it's there's a complete, I mean, freedom in how you design your algorithms. Okay, but yes, that's broadly, these are broadly the ideas.
Okay, okay, Professor. And one more thing is like you said, right? In order to calculate in TDD mode, we will transmit SRS to in the uplink. We will estimate the channel. We will do the pre-coding to the CSI-RS, find the PQI. That part I'm kind of confused actually. Like the thing is like how we can convey that like that given SRS CSI-RS is pre-coded or not to the
Given
UE.
Pardon? Given SRS, CSI-RS is included or not?
Yeah, to the UE actually. Is like because like so DMRS if you recorded means like it is a part of the data, so you don't need to convey the which pre-coded you use it for
Even
the
if, see, no, even if it is, I mean, CSI-RS is pre-coded, UE doesn't need to know which pre-coder is being used. It just simply estimates the channel and reports back the CQI for that. Then it doesn't send the PMI.
Okay, but and okay, I got your point, but like if it is pre-coded, we will only send the CQI. We will not send the other information, or like we will send the other information.
You can configure that it doesn't send the PMI because it's already pre-coded, or you could ask for that or as well. But if it is already pre-coded, you don't have to. Network doesn't have to ask.
Okay.
Yes. Just to add to the his question. So if we are using match filtering, let's say we use match filtering and in TDD conjugate beamforming we are doing, let's say at a DL side. So like if I'm going for zero forcing, how to calibrate for a downlink to precode for CSI-RS? Can you throw more light on that?
I did not get your question. Can you repeat that?
Like what I have seen with one of the papers are like generally if we are using a match filtering at inode B side. Yes, at the receiver, and while transmitting they'll use a conjugate beamforming and then they'll pass it.
Sure.
So let's say if I'm going for zero forcing as a receiver instead of match filtering. So at a TX, how can I pre-code that? Is there any techniques?
It doesn't, see, your precoder is independent of the receiver.
Okay.
So now I think I've taught that also. You use a particular precoder. Then
we run it for number of ports for a loop and all.
Based on a particular receiver which a UE uses. That's the point I made in the beginning also. That then UE will report a particular SINR. Okay, right, and then based on that SINR, network will send the SINR or MCS, and in that MCS the network will use. Okay, right. So if it is a match filter, it is like it will give you a poor SINR. And if it is a zero forcing receiver, it will give you a better SINR, and based on that, UE will report the MCS, and based on that, network will give you a particular rate. Okay.
Yeah.
Good evening.
Hello. Yes, sir.
Yeah, good evening, Professor.
Hello.
On the course feedback, I agree with other learners. It was a real value add. Because in academic courses also and even in professional life, we don't go that much deep into the 3PP recommendations and the specifications. So
Okay.
it was an excellent opportunity for me.
Okay. Where are you working, sir? Where are you?
I'm with Ericsson.
Ericsson. Okay. Okay.
So I have few questions related to examination. How many questions will be there in 3 hours?
You will be able to solve, sir.
Okay, no worries.
I don't remember now because I set the exam in the beginning of the semester.
Okay.
Okay. NPTEL forced me to
So
set
50 questions generally.
Okay.
Okay. Who said I don't remember?
And I had not given, but means other exam generally 50 question and every exam.
Okay. Yeah. So something like that. You'll be able to do. That's what we have. I made sure that you have enough time. You'll not have to rush through the exam, but I don't remember.
And the second question is that there are a lot of IEEE papers and other books like Dalman. So will there be questions from those also, or only from the
No,
lectures?
sir. Whatever you have done in the course, that's all.
Okay.
You have seen the quizzes, right? Or
Yeah.
whatever you have done those. So it'll be similar to that. Nothing different.
Okay. Thank you so much.
Hello, Professor. Once again, is it possible for you to share an overview diagram? So when the devices enter the network, because you showed the base clock the base clock synchronization and other things, but the entire process of the how the EU the UE acquires the channel information and locks on. So all of the detailed steps. Is there I know this is all spread across multiple lectures, the initial access part, but is there like an overview diagram, just to give the broad picture, the EU what the
I think I've covered that in the class. I don't have any other lecture to explain that, and I think there's too little a time to explain all that here.
Okay.
So if you have any specific question, which I can try to answer here. Okay. Yeah. So that I don't have also, and it becomes difficult to do it in such a short.
Okay.
You ask me any specific question, I can.
Hello.
Yeah.
Professor, just one question which I had regarding TB2. Normally, we see only TB1 will be used. Is there any use case commercially where both TB1 and TB2 will be enabled in PDSH processing?
What was TP1?
Transport block, I'm assuming.
Transport block 1 and 2, both.
Transport
The
block,
use
okay,
case
TP.
where both can be enabled.
Yeah. The rank is more than 4. Yes.
Okay.
Okay. Then for more than rank greater than 4, the second TP will be set.
Thank you.
Yeah, hi, Professor. Oh, one more question regarding.
Switch on your videos. It becomes difficult to see who's asking. If you don't mind.
Yeah.
If you can switch on your videos, it will be.
Yeah, I turned on actually.
Now I'm asking at this.
Oh. So just want to know about this number of CDM group without data.
Number of
CDM groups without data. Last previous week we got 2 questions. Like one is number of CDM groups without data 1 and number of CDM groups without data 2. So assume if we configured the number of DMRS ports as 2, so number of CDM group without data 1 is sufficient usually, right?
How many CDM group? I don't remember the exact numbers. Now the CDM.
Okay, yeah.
So how many port it can support? I think 2 it can support.
Yeah, 2 it can support. Sometimes we see in the another question they ask number of CDM groups without data is increased from 1 to 2, even number of ports are 2. Okay, so usually in which scenarios usually Gnode we will configure or switch from a number of CDM groups without.
No, each CDM group can support a particular number of ports. So if it is
Yes.
so based on that we'll decide that if number of port is 4, then we'll take I think we'll take the second CDM group 2 if I'm right. Based
Okay.
on that, we'll decide. It's very simple.
No, but like even number of ports are 2, but if you configure a number of CDM with CDM groups without data as 2, so which means like in the wherever like means like in the first CDM group we will transmit DMRS 2 ports data, but in the second RE we will not transmit anything, neither like PDSCH or
I
not.
think, can you ask, I think this is a fairly detailed question. Can you ask this question on the forum? We'll try to answer it there.
Yeah, sure.
Okay.
Okay. Yeah, thank you.
And TAs are there, they are noting. I think Yogesh, you're there, right?
Yes, sir.
So these kind of detailed questions you can ask on forum, and we'll be able to answer.
Sure. Yeah, sure. Thank you.
Is there going to be a part 2 of the course where we look more into the details of the DSP that goes into the design of the, for example, the receivers and other things, where we take a look at the specifications?
I was tired doing this course itself.
But we really appreciate, sir, if you do that. Something
I have
more.
no plans as of now. I'm sunk into other works.
And just to add for that request, one even scheduler also could be discussed, sir, if you for the
I
part 2.
know. These are like they're important blocks, but I've given you enough hints, enough dots, enough references so that you can learn from them and build on top of it. So
Yeah, very true. Thank you so much for this course actually.
who's speaking?
Sir, this is Kiran.
Kiran, okay. Kiran, where are you working?
Sir, I'm in Capgemini.
Capgemini, okay.
We work on stack L2 and above. So L1 side, it was a good understanding, but
okay, good. There's a question on the chat. 1 second. Looking for L2 related intensive deep understanding. Yeah, there should be a course on L2 also. I'm not an L2 person, so I cannot help you there, Chetan.
Yeah, sir, but good evening, sir. So yeah, I'm following your sessions, and it is very, very in depth for 5 layer. We had interaction last time also.
Sure.
So yeah, thanks for the sessions, and yeah, looking forward for anything which is coming from your side. Will be happy to learn.
Let's see, Chetan.
Yeah.
Currently, I don't have any plans, but let's see. I never say no.
Thanks, sir. Yep.
Any other questions, please? Go ahead.
And yes, Sandeep here. So do you think the millimeter wave use case will be more in coming years? Because I heard stories in Korea, some vendor deployed it and then they gave the spectrum back to the government. So in India, you think that in terms of Indian vendors will be more eager to deploy millimeter waves?
I don't know how much. I've not personally heard of any such thing, but yes, see, there was this discussion that 5G is not like as successful as 4G or.
Yes, yeah.
The thing is that if you look at it, it's not about the standard. It is about the time. Like when 4G came, then the smartphones were becoming like popular, right? 4G was around 2010, and then Apple came up with their phone, and then everybody started making these kind of phones, right? And then suddenly there was a huge demand for data rate, right?
Yes.
On a mobile, you could see everything, you could watch videos, you could do whatever you want to, right? So that was. And that's where the time aligned when the 4G came. And it was 4G was coming, these devices were coming, and people were starting to use them. Then and 4G could provide that connectivity, that kind of bit rates which these application asked for. Now, what you asked about 5G, is there any such application is there, like which people are which people say, okay, 5G has enabled that. Okay. Right. So whatever you could do with 4G, you are able to do with 5G. There's no such difference. And there are like these Apples and all these companies, they came up with these AR, VR headsets, which people did not like. None of us is willing to wear those headsets and roam around.
Yeah.
Right? Okay. And so that's there are very, very niche applications like this, but otherwise, whatever like 5G, that way there has not been able to provide, or there are no such applications to use that 5G power of 5G. So operators are saying that they're not like the kind of investment they have made, they are not able to like generate those kind of revenues. We are hearing that, but still people are like going ahead and everybody in India have deployed 5G. Right? So give them more subscriber density, whether the larger bandwidth, and they can enroll. You can get continue. I mean, you can get your bit rates will not drop down because the bandwidths are higher. Other than that, there is no such niche application which make people go gaga over 5G. So that's the current scenario.
Also, for the millimeter wave, when we did the analysis, the cost, the amount of energy cost, it's prohibitive to support millimeter wave. It's not just that the cost of the equipment. We often get these reports, and some of the reports are public. To support those bit rates, there was this question why we are not doing, MIMO in at millimeter wave. The reason is with 400 megahertz, if you try to do MIMO, not the beamforming, the other one, what will happen is you will need to support the SerDes in your phone, and the amount of battery it will draw. We are not there yet from the technology point of view. We keep getting.
You're right, because we have to see you have to do this recording over the entire bandwidth because you're doing analog beamforming there. Okay, so yes, and as I said, it's like you are absolutely right. And then the first concern is about the connectivity itself. Okay, and people have not been able to fix that. So that's where it's the use case is limited only to these like fixed wireless access where there is a clear line of sight. Any other questions, please?
Do you think there will be changes to the protocol to enable, because everybody here keeps talking about not particularly in the India context, but in abroad where we do not have our own energy sources and other things, we have to rely on imported energy, and energy is a big cost when the telecom operators look at. Do you think there will be changes to the standard to 5G covered almost every use case, but it made things a little bit more complex from the digital side of things? Do you think there will be changes to the standard going forward where
People are talking about it. People are talking about it when we look at the ITU definition of 6G. Okay, so energy per bit has to come down radically. I think by a factor of 10, if I'm not wrong. Okay, or maybe 100. Okay. So yes, ITU is talking about it, and when it is defining 6G now, and 3GPP will have to design. We'll have to design standards accordingly. There will be effort, and that's a big concern. Yes, and the amount of energy being consumed is extremely high.
What do you think will be dropped? What do you think will be the low-hanging fruit when it comes to the energy consumption? What are people thinking about? Like, what is the first thing they will try to do to reduce the energy?
These solutions are being there around. The easier ones will get implemented first, but they were known even for 5G, but we don't see people implementing them. Like smart scheduling of switching off the base stations when there is a low, there's something called SON, self-optimizing network, where you switch off one network, one base station when the subscriber density is low. But this requires like much more interaction between base station, and that's where people struggle to send this kind of data across. These are like, so you switch off one base station and serve from others. If people are like successfully able to do that, that itself will bring down the energy cost. We are not seeing that happening. All the base stations are transmitting all the time. Right? So, simple solutions like that, scheduling helps a lot. Though there are much more sophisticated solutions, you can design your system, we work on it. Then you can look at the metric itself. Instead of spectral efficiency, you look at something called energy efficiency. Okay. So you can design your system based on that. You don't maximize the spectral efficiency, you maximize the energy efficiency of the system. Okay. So and that changes the approach. But that's more sophisticated way of doing it. I'm saying a simpler one will help from and that itself is I don't see that happening in the network. So if we do that, that itself will help.
Hello, Professor.
Hello.
Good evening. I'm Pankaj. So actually, I have earlier worked on 2G, 3G, and then actually 5G RU related DFE and the other stuff development. So this 5G related standard actually I was familiar but had not worked. So actually, this is a great course, and I actually learned a lot. Means I have still yet to finish all of your lectures. So thanks again for a great course. So I have actually few questions. Means they are not necessarily means related to the course content. So first of all, actually, what next that we can focus after this course? So this is one question. Then another question is that like if we try to understand the IEEE papers related to maybe 6G or anything, then there is lot of heavy math around it. So what is the effective way of reading such papers and getting most out of these things? Then the next question is actually like I read on your LinkedIn profile that you have recently been awarded a patent. So actually congrats for that. So can you tell more about that, and what are the areas of exploration for generating the innovation ideas for 5G and 6G? So these are some of my questions.
Very broad question. Who is this?
Pankaj.
Pankaj. Oh, 1 second. Let me spotlight on you. I can't see you. Yeah. Yeah, Pankaj. So see, this is you have to look at relevant papers. There will be papers without math. So you look at the conference papers.
Okay.
And don't look at the journal paper. That is one. You're working somewhere, Pankaj?
Yes. I work with Economics India with respect to 5G advanced and 6G also. We have started. So
yeah. So yeah, better way to like look at papers is to search for conference papers.
Okay.
And then look at these standard relevant papers. Then you can see release 18. Search for keywords like release 18, 19.
Okay.
And conference and magazine papers. Okay.
Okay.
If you search for a journal paper, we also write a lot of journal papers. Then like they'll be heavily math oriented. But there are these conference papers which will give you a good idea of what is happening.
Okay.
If you really want to contribute, then you have to attend 3GPP meetings.
Okay.
Where my team attends the standardization meeting, they travel. In fact, they're traveling tomorrow to attend a meeting in China. As a company needs to attend. Okay, that's what if I can like motivate some of companies to attend these CGPP meetings, I'll be happy and contribute like that. Otherwise, there's no point. Okay.
Right. That's true.
And you have to like when that one cycle of standardization goes for 2 years, and you have to attend all the meetings and then first patent your ideas. That's what you saw in my LinkedIn. That I patent
Right,
you.
right.
I have to put them into the standard so
Right.
that it becomes something called SEP, Standard Essential Patents.
Right.
So that's what you have to do. And the topics to work on, which become part of next release, you have to see what is happening in the standardization meeting. What is the focus
Okay.
on? And you have to come back there. Typically, what happens is there is a team which is working, there's a back-end team which does all the basic research, and then the person, there are these persons on the front end who take these ideas. Of course, the people in the front end also contribute. Take these ideas to standardization meeting, maneuver the discussion there, and so that these ideas get accepted. Okay, so this
Okay.
happens online, in emails. It happens in online discussions. You have to upload something on T-Docs, technical documents, so that discussion is maneuvered accordingly.
Okay.
So that's how you have to do. There's no other way.
Okay.
And if you want to do deep theoretical research, then of course you have to do a PhD.
Yeah, that's good.
Right. So that's, and we do all that. I do a lot of theoretical research, and you're welcome. All of you are welcome to see once these PhD applications are out, or MS applications. So we keep hiring also people. I'm advertising. Okay, and that you should know. And we do a lot of theoretical work when we publish these highest end journals, conferences. That is typically done by PhD students. Then there is the standardization team which travels, they do standardization work. Then there is an implementation team which builds the network. So I do all three kind of work. If you're interested, you can mail your resume.
Sure. So, are there any part-time PhD considerations in your group, or you accept only full-time students?
Typically, I prefer full-time, but if there are IIT has part-time options, when you come here and do courses for a semester and then you go back to your company. So we allow that also.
Okay. Okay.
But for a semester, you have to be here. Semester is basically 3.5 months.
Okay.
Okay, so then you can do your research remotely.
Okay.
I personally prefer regular students so that they can focus on it. But off late, I'm doing it case by case basis.
Okay. Okay. Thanks.
Hello. Hi, sir. This is Nikhil, sir. Hello.
Hello, yeah, Nikhil.
Yeah. Hello, sir. Firstly, I'm very thankful to you for this wonderful course. And sir, I have one doubt, that I didn't understand the concepts of a port and physical ports and logical ports, and means I face difficult to visualize actually those things.
This is slightly different. I tried explaining in the class. So a port loosely refers to the number of orthogonal pilot signals you are sending. Okay.
Yeah.
Which the UE can differentiate. Okay, that if you're sending one port, if you're sending one orthogonal pilot, it's called a one port. Okay, it's called one antenna port. Because that's what UE will see. Okay, that it is, even though it is like you can be using hundreds of antennas, 64 antennas, 128 antennas, but if you are sending a single port pilot, okay, then it is called a single port. It's called single antenna port. Okay, and the single antenna port basically is, you start using these terms when your transmit signal is pre-coded. Okay.
Okay.
Let's say you have you are doing pre-coded transmission. Okay.
Yes.
Okay. Let's begin with when you're not even pre-coding. You want to estimate the channels. You want to, let's say you have a 32 antenna system, and UE wants to estimate the complete channel. Okay. So the base station will send a 32 antenna port pilot CSI-RS.
Okay.
So because it's sending 30, that the detailed concepts are explained in the slides, but that's what I can tell you now briefly. So
yeah, sure.
send 32 antenna port, CSI-RS so that UE can estimate. And it'll basically UE will estimate the channel. It will then report back the PMI and MCS to the base station. PMI is decoder matrix indication. So base station, with this base station will have a decoder matrix. Base station knows what decoder to use for this particular user. Okay.
Okay.
Now, once it precodes, it knows the rank of the rank will also be reported by the user. Okay. Right. So rank means what? Number of layers.
Yeah.
With the number of layers, so it has to resolve number of UE. So what will the base station do? It will, based on the number of layers, it will send, if the number of layers is 2, it will send 2 port DMRS to the user. Okay. And it will decode the signal accordingly.
And sir, like logical port means like they have similar subcarrier, means it will be in one resource grid, or the resource grid will be separate.
Can you elaborate on your question?
Means sir, like that resource grid means each subcarrier, each pilot each pilot symbol means like is it like one separate resource grid, or it will be in the same resource grid, like the ports?
Port will be okay. I kind of understand. You can write your question also in the
yeah,
try to answer there also. But I think see the resource grids, when you have these ports, okay, so you basically have 4 different. If you have 2 port, you'll have 2 different parallel resource grids.
Okay, separate. Okay.
Yeah, in parallel.
Okay, sir. Yeah.
Right,
Yeah. Yes, sir, and thank you, sir, for explaining. And yes, absolutely, your course is very wonderful. I used to work at Qualcomm, and I
Where are you working now?
currently I'm at Mavenir, but for like 3.5 years I worked at Qualcomm. I began my career from there.
Okay. Where did you graduate from?
IIT Madras, sir.
Okay, you did your MTech there, or BTech
Yeah,
there?
MTech.
With whom did you work?
Shri Krishna Bhashyam, sir.
Oh, Sri Krishna is a friend.
Yeah.
Okay. When did you graduate from there?
2020, sir.
I was there till 2016.
Yeah. Yeah. Thank you, sir.